Hey everybody, welcome to our second video on the EmSAT Math 2020. So we're solving questions 6 through 10 in this one. So let's get started with number 6. It says line segment A prime B prime has endpoints A prime at 4 minus 2 and B prime at 16, 14. And it's the image of line segment AB after a dilation of 1/2 centered at the origin. What is the length of AB? So there's a lot of stuff to talk about here. Let's start talking about, enlargements and dilations. So when you have an original segment called AB, that's made of two original points A and B. And after you enlarge it or you scale it down, then you end up with images called A prime and B prime. We call them the images. So A prime, B prime is the image of AB. That means that there's a factor, some kind of, a number that you're multiplying to AB to get your new line called A prime, B prime. Okay, now we have these 2 points, A prime, B prime. So why don't we put them in this grid that I've made ahead of time for me and you. So A prime is at 4, -2. So that's, let's assume -2's right there. So let's call this one A prime. And then you have B prime, which is at 16 and 14. So 14's somewhere right around there. So let's place it somewhere here, okay? So let's call this one B prime. And I usually like to write down their coordinates so I don't have to keep looking back and forth, There you go, easy peasy. Now it says that there's a dilation of 1/2 centered at the origin. So when they're saying it's centered at the origin, we might as well draw this line, okay? Here's segment. So when they say it's centered at the origin, what that means is the transformation took place from the origin. So it's like something along these lines. So any enlargement or shrinking you're doing, you're just going to be moving B prime closer or further from the origin along that line. Same thing for A prime. If you're enlarging it, it goes up that way. And if you're shrinking it, then it goes that way, always along the line towards the origin. So that's a good start for us. So now I know my original points are somewhere on this line. Now, since we know that the dilation, they said, is a factor of 1/2, what that means is that this line shrank. This means that 1/2, because that's my dilation factor, 1/2 of AB is equal to this A prime, B prime. Well, what that means is that AB, with a little bit of algebra, is equal to A prime, B prime divided by 1/2. And if you know how to divide by fractions, it's like multiplying by the inverse. So that means it's A prime, B prime times 2. So essentially what they are telling me is that AB is twice the size of this line, A prime, B prime. Okay, so now we figured out that our original line will be twice as big. But how do I place it on this line? Well, that's where step number 2 comes in, okay? So secondly, that's what we're going to work on. So what this is telling me is that A, the point A, his coordinates are going to be twice the coordinates of A prime. So what are the coordinates of A prime? We already have them, right? They're written right there. So it's 4 and -2. So A will be found at 8, -4. Now we're going to do the same thing with B. It's going to be twice the coordinates of B prime. So it's going to be 2 times 16 and 14, meaning it's at 32 and 28. So now let's place these 2 points. Let's place A, which is at 8, -4. So that's 8 and -4. So I kind of missed the line a little bit, but remember, I'm doing it freehand. If you were to do it on a proper graph, I think you'd get a little bit more accurate, but I hope you guys get the point. When we talk about B is at 32 and 28. So again, it's approximately all right. For freehand, it's not that bad. Okay, so 32 and 28. Let's draw this segment. And now we're not done, right? Because that last part is actually asking me, what is the length of AB? So how do I find the length of AB? Well, that's where Pythagoras comes in, okay? So part 3, let's do part 3 over here. Thirdly, you have to do a Pythagoras situation. And Pythagoras says that for any right angle triangle, A squared plus B squared equals C squared. So let's pretend this is C. This red line is C. And check this out. This is a right angle triangle. Here is one side and here's the other. right? And we got a 90 degrees over here. So the green side, let's call the orange side A. Let's call that green side B. So how can I find A? Well, this is the way you do it. You do XB minus XA, okay? You're just trying to, if you really want to, you can just count each square. It doesn't matter. How do you go from 8 to 32? It's 24. But technically what you're doing is subtracting. It's 32 minus 8, right? So that orange side, which we called A, is equal to 24. Now how about that green side B? Well, I'm going to do the same thing, but it's in the Y direction. You say YB minus YA. And again, you can just count how many squares. If I'm going from -4 and I'm going all the way to 28, that's going to be 32 spaces. But if you want to just rely on the equation, that's totally fine. So you would get 28 minus -4, which is 28 plus 4, which is 32. So now that I got my A and B, it's pretty easy to calculate C, right? C squared is equal to A squared, which we found to be 24. Plus B squared, so here's my B squared. So if I want to find C, now C is equal to, you can punch it in your calculator and you get 1600. And if I want C by itself, then I have to do the square root of both sides, right? Square root, that gives me C. And the square root of 1600 is 40. And there you have it. Correct answer was A. The length of the line AB, the original line AB, is 40. All right, so first what we did was, figured out the original relationship for the enlargement, which was AB, the original, is twice the length of this image that we've been given. Once we found that out, then we took the coordinates of A prime and we doubled them, took the coordinates of B prime and doubled them, and found our AB, right? So as we suspected, they were basically along that line because I'm doing it freehand and it's not that great. Once we got the coordinates, we put them on the graph, and we notice, of course, that this forms the hypotenuse of a right-angled triangle. A is the distance in the x direction, and B is the distance in the y direction. So once I figured out those distances by subtracting their coordinates, xb minus xa and yb minus ya, then I got the length of the legs of that right-angled triangle. Knowing that, I was easily able to calculate C. So let's move on to number 7. This question says, in the diagram below, right triangle ABC has legs whose length are 4 and 6. What is the volume of the three-dimensional object formed by continuously rotating the right angle about AB? So there's a lot to digest here. First of all, we got to figure out what kind of shape are we going to get when we rotate this triangle about AB. Where is AB? It's right here. It's this one, this line right here. Right? So if we rotate about AB, what they're trying to tell you is that this whole thing, this whole triangle will be spun around in this direction, if you can picture, around AB. And if you were to do that, what you would end up with is like a sideways cone. And I'll try to draw it for you guys in 3D. So let's say this is the axis AB. Then what you'd end up with is a cone like this. That's what it would look like. So this would be like point C, and you'd have point A here at the base. Maybe you can put it over here. And this is point B. So we can figure out a lot of our lengths, right? So this over here was 4 units. And from A to B, this one was 6 units. Now, what are these values when it comes to a cone? So the base, of course, is going to be a circle because you've spun it around. Remember, you spun this around. It's not very 3D-like, but I hope you can try to imagine. So the 4 is actually the radius of that cone, is 4 units. That's the radius of the cone. And this 6, if I were to just, redraw it along here, from the vertex coming perpendicular into my base, this is called the height. So the height is 6. Now the equation for a cone's volume is pi r squared times h over 3. So let's go ahead and substitute our values into here and see what we get. You get pi times 4 squared times 6 over 3. That means pi times 16 times 6 over 3. This gives me pi times 96 over 3, which gives me 32 pi. And we don't have to put that in a number because they want it in terms of pi, right? You see the answer is always in terms of pi, and the correct answer was A. What you had to do is kind of imagine what kind of shape you would get if you were to rotate this triangle about this axis. And I hope you can picture that. If anything, you might want to take a triangle at home, any triangle, and try to spin it about one axis. Even if you put it, rotate it around your finger, and you'll kind of notice that it forms a cone whose height will be along the axis, right? This will be the height of your cone from the apex to the base. And this one here would be your radius. The radius of the base. All right. So I hope that helps. And now let's move on to question number 8. All right. So question number 8 says, write the expression below in simplest form. So these are called surds, and it's not that bad to solve them. One main thing you need to know is all your squares. So let's write them down. There's 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. I'll show you why we need this. Okay, 5 squared, 6 squared, 36, 7 squared. I'll probably just go up to 10. I hope you guys will get the idea, and then you can do it on your own, right? Because that's the whole point. So here we go. These are all the squares, right? So whenever you have a surd and a root that you're trying to simplify, what I want you to do is this. Let's try an example first. Let's try something like 72. I want you to break up the number 72. I want you to break it up into a product of 2 numbers. One of them has got to be from this list here of perfect squares. So what's the biggest one that fits in here? Let me see. 1, 4 works, 9 works. The biggest one though, the biggest one that works is this guy, 36. Okay, so I'm going to pop in 36 here. I'm going to rewrite 72 as the product of 36 times 2. You see, this is correct. I haven't broken any laws here. I'm doing fine. So now let's continue. Second step is that I can break up these guys. I can break them up as a product of 2 completely separate roots. So now I have square root of 36 times square root of 2. And here's the nice part about using the perfect square from this list, is that the square root of 36, as we can see from here, is simply 6. So the answer to this simplification would be 6 square root of 2. So let's try doing the same thing with this a little bit more difficult, minus 300. So minus 300, what I want you guys to do is try to break it up. So what's the biggest perfect square we can use? Let me see. There it is, right? It's going to be 100. So let's put 100 times what? What's this going to be? Well, it's going to be -3. Okay, second step is the same. What you got to do is break them up. So this is like they each get their own root. So nice thing about the perfect square is it's 10 times root -3. So let's do this -3 on the side here. Can you think of 2 numbers whose product is -3 and one of them should be a perfect square? Well, from the previous questions, I hope you remember that we can use -1. -1 times 3. How does that work? Well, let's do the same thing. We break them up, right? So you get -1 times root of 3. And we know that the root of -1 is called I. Right? So what I'm going to do here, I'm going to substitute. I'm going to say 10, but instead of -3, I'm going to write I root 3. And there's your answer, people. A. Big surprise. So this is how you break up surds. I've given you one, simpler example up here. But you can also do it with a negative. In case you have a negative, just remember you want to get -1 out of there as fast as you can. And -1 is like a perfect square that simplifies into I. All right. Let's move on to question number 9. This question says, select all values for which m is the following expression defined. The syntax is weird, but basically they're asking you for what values of m is this expression here going to be defined. Well, this expression will be defined so long as the denominator, that means the bottom part, is not equal to 0. So anything which makes the denominator 0 will leave this function or this expression undefined. This is because in math we can never divide by 0. Never divide by 0. Okay, even if you put it in your calculator is going to get mad and shout at you, and it's going to say syntax error, math error. Don't do that again. So all I'm going to do to find out what makes it undefined is just look at the denominator, which is 3 minus m. And to find out what we're not allowed to do, we have to find out what makes it 0. Now this is a one-step equation, so I'm not sure if you've seen it, but we have a lot of other videos on algebraic solving. The way we're going to do this is we're going to shift the m all alone on the other side, and since he's a minus m, I'm just going to make a plus m, which is the inverse, and that right side gets very jealous and he says, me too, me too, me too. So you have to give him a plus m as well. Now these two cancel out. You end up with 3 equals m. So for this value, the denominator equals 0. So this value is not allowed, right? Not allowed. So anything else is fine. So in fact, the answers are going to be A, B, and C. See, the only one that's not allowed is D. All right. Whenever you have a rational function, just remember you are not allowed to ever divide by 0. So you just set your denominator to 0 and solve for the variable, whether it's m or x or whatever it is, and you're not allowed to have that value. That's it. In a graph, what that would look like is a vertical asymptote when your variable is equal to 3. So this graph would look something like, something like that. Okay, let's move on to question number 10. So it says, suppose that minus square root of 7 over 3 comma y is a point in quadrant 2 lying on the unit circle. Find y. What they've done here, they've given us the x coordinate of some point, and they're telling us to find the y coordinate now. What is the unit circle? So I've drawn one here on the right. Basically, it's a circle which has a radius of 1. Okay, that's why it's called a unit circle. The x-axis, as you know, is right here, and the y-axis is the vertical one. So what we know is that the x-coordinate is minus root 7 over 3. So minus root 7 over 3, now that's a negative number, right? So it's somewhere here, okay? Somewhere right about here. That's minus root 7 over 3. And we know that there's a point that lies on this circle. So the point is right here. And what we're trying to figure out, we're trying to find out, the height of this one. What is the y coordinate of this point? So lucky for us, like we just said, we do know that the radius is equal to 1 in the unit circle, right? It's always equal to 1. And if you notice, this looks exactly like a right angle triangle. There you go. So all we have to do is actually use Pythagoras here. And I'll remind you of Pythagoras. It's a squared plus b squared equals c squared. For our case, let's assume this one is minus root 7 over 3 squared. The y coordinate, which we don't know, which is the height, we'll call it y squared. And we know that c squared, that's a hypotenuse. It's 1 squared, which is equal to 1. So we can clean this up a little bit. I'll tell you about this exponent. When you have an exponent to a fraction, what happens is that your exponent's going to get distributed to both the numerator and the denominator. So what you end up with is minus root 7 times minus root 7, which is 7, and 3 squared, which is 9. And we still have our y squared, and 1 squared, of course, is just 1. So what I'll do next is I'm going to try to get the y squared alone. What I'll do is do minus 7 over 9 on this side, and this side is jealous, he needs the exact same thing. These two cancel out. What I have remaining is y squared equals 1 minus 7 over 9. So we can take the party to the other side. So let's do this. It says y squared. Now 1 minus 7 over 9 is 9 over 9 minus 7 over 9, which is 2 over 9. Okay. How do I find y by itself? Well, since it's being squared, I'm going to have to square root this side. Jealous guy says me too. The square and the square root cancel each other. I got y equals, now whenever you take a square root, remember, it can be plus or minus. What I mean by that is, here, I'll give you a quick example. Let's say I have the number 9, and I say, what is the square root of 9? Well, the square root of 9 is either 3 or minus 3. And the reason is you can do 3 times 3 or minus 3 times minus 3, and both of them, of course, will give you 9. So whenever you take a square root of a number, remember you got to take plus or minus. Okay, that's where this one comes from. So let's do it over here. That means that y is equal to square root of 2 over 9, And just like the exponent that gets distributed, the square root can be distributed, which means this is square root of 2 over square root of 9, and square root of 9, of course, is 3. The other answer would have been the negatives, right? So it would have been minus square root of 2 over 3. Now, how do we know which one is our answer? Well, here's where the quadrant thing comes in, okay? These are the quadrants. 1, you always start top right, and you move counterclockwise. That's quadrant 2, that's quadrant 3, and this is quadrant 4. Okay, we use Roman numerals to describe them. So they told us that it's in quadrant 2. Now, why does that matter? Because if the y coordinate is square root of 2 over 3, that's positive. That would mean somewhere here. And if it was minus square root of 2 over 3, my point would have been the one down here. We'll make it purple or something. It would have been the point over here, which has a negative. This one is positive. So since they've told me that it's in quadrant 2, I know that this one here is my point. This is the correct answer. And that's why we have to take the positive one. We will ignore this one here, making our answer equal to A. So I'll just recap that. When you have a square root, you're going to end up with a positive and a negative answer. Now, how do we know which one to take? Is because of the quadrant that they've told us to use. They've told us that the point is located in quadrant 2. In quadrant 2, you have a negative x coordinate and you have a positive y coordinate. That's why we use the positive one. So that's the end of this video. We'll be doing the next one on questions 11 to 15. Make sure you like the video and subscribe to the channel. Please leave us any comments, feedback, suggestions, and we'll see you in the next one. Thanks.